Now, just before we dive straight into this, my name is Yarik. I'm a Rails engineer for like 10-something years, and let me start. My talk is, the title of my talk is Two Requests, One Record, and we're gonna look into some concurrency-related things that how I thought gonna be useful for middle plus engineers, but apparently sounds like we got almost no middle engineers here, but still, let's see. Anyways, let's get started. So I'm gonna need to, all right, so first of all, let me just quick introduction. So concurrency is not something you choose, and just a brief story. So I started with Ruby on Rails like in 2014, and before that I was working like for a year as a C#.NET engineer. And even that year was enough to me when I switched finally to Rails and Ruby to realize in a short time that there is like very different vision into like on development when it comes to like .NET, maybe some enterprise-like engineering versus like how the majority of Rails startups / mid-sized projects think about everything in this world. I'm not talking right now about companies like GitHub, likely they do things properly. I hope so. At least. But exactly, yeah. But the vast majority of like smaller, like to mid-sized Rails applications that I encountered in my life, they actually were kind of short on that. And what specifically I mean, you see, like in .NET and in C# world, like people would treat concurrency and data safety like kind of differently. Like it's gonna be like a first-class citizens essentially in the way you design your applications, and you will think about it from day one. You would build your entire system around this. And here in Rails community, it sounds like people usually start thinking about it when they get first problems, like when they start seeing like duplicated transactions, when they like lose data, when they like etc. So that was kind of the idea and the reason that I decided to like come up with this talk to maybe remind middle engineers that how to not do things and what the common pitfalls are, and likely to remind everyone that we need to be mindful about designing our systems from the very beginning, because like as the time goes, it becomes harder and harder to fix things as you go. With that said, let's get started. So I'm not sure if you can actually see the screen, but I hope you can. Like there is not really much to see. So what we're going to be doing today, we're going to talk through designing like the most simple service application in the world, and we're going to just cross some bridges and like see how like some problems that come up and like how you could solve them if you want, hopefully. And what we're going to be doing is like the most simple service or like endpoint, think about it, like doesn't really matter in the world. So we're going to be implementing like a marketplace purchase endpoint. So as simple as that. Literally just three things we're going to be doing. We're going to be charging our buyer, we're going to be transferring money to the seller, and we're going to be creating the order. Like literally three things. And if you look at the average Rails projects, and that's also something that, I mean, the company I'm working right now, we also like have something like this. We are kind of like still working on, but long story short, like you can see something like this. So again, unfortunately, I'm not able really to see it, so I will need to maybe like take a, yeah. So here is like the idea essentially, right? So usually the way it happens is you have a very simple endpoint. You have like your buyer, you have your seller, you have the amount, right? And you want to like essentially create a transaction. You want to do it like in a safe way. So we all know that like we are supposed to be using transactions for that, right? So what you do is very simple. You find your wallet, buyer wallet, you find your seller wallet, you run your business logic that can like in this, it doesn't have to raise anything, obviously, like just like some random business logic that you could have in place. And then you proceed with essentially persistent data and doing whatever you want to do, right? So the most common, the most simple approach in the world. And you write tests and they pass, and it actually works. It works in development. It might as well work in production for a very long time, like until you reach like certain point. And this is how like the majority of companies, at least I think, start. This is what they start from, right? So as simple as this. Now, it all works well, and everyone is happy until obviously one day, and I'll go briefly through this, you hopefully start getting more traffic, more people start using the service, right? And then we start encountering like just the most obvious race conditions in the world, where essentially you have just two threads running simultaneously, and both of them just are trying to do relatively the same thing, just with 3 milliseconds apart. And they obviously both read the value, they both check something, right? They run some business logic, and they end up writing something to the database. Obviously, you're gonna like, this is just a classic race condition, obviously, explanation, right? So nothing really new here. Nobody is happy about this, so you would want to fix it, obviously, right? And this is where things become really interesting. And now today that we had already like plenty of topics around kind of concurrency, and specifically even like in databases when it comes to multi-threading. So obviously, let's just like in a few words, right, like talk about why we have even the problem, right? Because also for what I realized is like some people, and I'm not saying it's bad, it's just like how it is, like it's really important to understand like what the transaction is. And we are not gonna dive like into like very database specific, like Postgres specific in my case, for example, things. We are just gonna talk like in a very high level. So essentially, the database transaction is actually a very simple thing, right? So you have your isolation level, which like by default is read, commit, repeatable read, depending on like, again, mostly focusing on Postgres because that's what I have the most experience with. Then on top of that, you have your transaction with multiple statements, right? And obviously your statements see the data the way it is at the moment you run your statement under the default isolation level, obviously. That's where the problem essentially comes from, right? Like the moment that you read your data and the moment that you do something, things change, and they change a lot as long as your application is concurrent enough. So that's also something very important to understand, that like it's not because database transactions are broken in any way, like they work, they just never guaranteed you to do what like some people think they guarantee. Like they never promised you to save you from race conditions. They just promised you to persist the data, some data, not exactly what you expected it to persist. Right, so with that said, let's move on. So what is, again, I hope you can read it, I bet, which isn't bad. I mean, essentially what we are trying to do, right? We are, the very first solution that obviously comes into everyone's minds is just, let's just use logs, right? Again, like it's worth mentioning that even like at this point, it's actually really interesting that understanding of like select for update, like a lot of people just think that that's everything you got, right? Like for example, select for update, you just log the record and that's it. First of all, something very important is that like there is multiple versions of the select for update, obviously, right? You can like select it for no key share, whatever else. But for some reason, the default Rails behavior, I believe, right, is just select for update. It does not even like try to do anything smarter than that. And that's so essentially what we're doing right here is we got our, we still have our buyer, and we still have, it's really hard to see at least anything, I'm sorry about that. So we got seller, and we essentially log the buyer, we then log the seller. We again like run our validation business logic, and now we are sure that whatever we are checking is actually what it is. Then we proceed with updating the records. And again, since we log them, everything is going to be fine because nothing can change in between. Well, assuming everything takes a look, right? And yeah, then we update our records and we create an order. It actually works. We deploy it. It works. Everyone is happy, it's safe for now, right? Now, it's safe, but not really, because obviously we always need to keep in mind that, and it's like, again, for a lot of people, it may be obvious at this point. For some people, it's not. Like the order that you take log really matters. You need to be very careful about it, and that's where essentially where the most complex probably part comes in, because it's not about the logs at the end of the day. It's about the application design. It's about like how you essentially build it, and like when you have an application that didn't care about like these things from the very beginning, you can tell it immediately, and it's really hard sometimes to actually get it done properly then. So just let's do everything properly from start, from the very beginning. Well, I mean, obviously for this case, right, this is a classic deadlock, nothing even to explain here. We just locked all records in different order, and we deadlocked, and at the end of the day, like one of the transactions is gonna be killed, and the other gonna be happy, gonna proceed happily. Obviously, the way to fix this is very simple, well known. We just need to ensure that we acquire locks in the same order, in granted order, so we just sort the records, right? Nothing really complex about this. All right. Something that also we need to keep in mind is, and again, it says nobody sees coming. Like again, a lot of people probably can see this coming, but something to keep in mind is that like you can deadlock, obviously, even updating multiple, not unrelated like entities essentially. So it's not just before. It's not just between like the same rows of the same table, but also between just different rows of different tables. So again, in this case, we come back to the fact that you can't like solve it with sorting in this case, right? So we come back again to just designing your application properly and making sure that you have your persistence layer, your business logic layer in a way that enforces these locks in correct order and guarantees that they are taken when they have to be taken. And it requires obviously a lot of thinking. And from my experience, it doesn't really work well with things like callbacks a lot of the times. Nested attributes, a big question. Again, like it just requires you to approach the application slightly differently. I'm not saying it's not possible, maybe I just don't know how, but it's just much harder to do. All right, now that we are done with this one, so we're just reminding like we fixed it by obviously sorting the records in the correct order. What we do now is the following. Everything works fine, and then one day, and this is, by the way, like an example from the actual application that I personally worked for. And in this case, obviously, is very explicit, and you can see it easily. But keep in mind that, like in your application, that like your production-grade application, you could have like 15 layers of like things happening, right? And it's actually super easy to accidentally call something deep inside of some code. So. Like in this example, right, what happens is your product comes back to you one day and they are not happy anymore that their users have to essentially complete 2 independent flows. They have to top up their wallet explicitly before proceeding with transaction, right, with payment, with purchase. So what they want you to do is they want you to auto-charge the amount that isn't like essentially the difference between like what the customer has in their internal wallet and with what you are trying to charge them. They just want you to top it up on the fly. And again, this is literally the one of the examples that I saw like in real applications that actually work for a lot of people. So one of the easiest solutions that you can do easily is just like dump it in the end of the transaction, which is going to work. And it sounds. What's actually interesting is it is defensible in a way. Like when you start arguing with like people sometimes about like why is it bad, you can like until you actually go through everything, it's actually very easy to think that it's sort of neat in a way that you like think about it. Like first on the left, right, we are done with the database at this point. Like we updated everything, we logged, we updated, and at this point nothing raised, right? So it kind of tells you that everything going to be fine going forward. So like it's kind of convenient to just like go and charge Stripe, and if it doesn't work, then the charge raise, for example, the whole transaction rolls back, and you are kind of like good to go, right? And on the other side, if everything goes through, then when the transaction commits, your charge went through, and you charge the customer, and you update everything, right? So again, this is very aggregated example. You can have this API call deep under the hood, etc. So essentially, obviously. And this is also one of the things that can work for years, and in our example, for example, for like multiple years, in fact, until one day something goes wrong, and you start seeing delays in external API responses. And also, by the way, keep in mind that like this is like a Stripe example with external API. It might as well be literally anything that is not like your database. It can be your Redis at the end of the day, by the way. So you can't guarantee that your Redis connection is like healthy enough, and it won't like essentially force your database transaction to remain open for like few seconds, which is more than enough in the high load system to, not even high load, just any like barely used system to essentially start having problems. And long story short, that's what happens. And the entire system at this point becomes like uncontrollable, and it's really hard to understand what's going on, because like the log's going to be like, the database log going to be really crazy. Like the load on the database will be also interesting. You're going to see a lot of, it's like, unless you experienced it, it might be like really confusing as to like where to even like start looking for, what even like start looking for. So long story short, again, this might sound obvious, but like database transactions, they are for databases, which means that we just don't touch anything else except for our databases and like the bare minimum of business logic within this, within the transactions. And how we fix it? Well, again, like the problem is that we fix it by redesigning in a way by redesigning the way the system works, right? So instead of like relying for happy paths and just doing everything like one by one, we essentially introduce this. We accept the fact that we can have like desynchronized system in a way. So for example, in this case, we can fix it by first introducing the concept of available balance, and then introducing the concept of pending order, right? And again, available balance, you need to be very careful about how you implement it, because you also need to be using proper database queries to reliably get it with all the pending orders in place, etc. But long story short, just to not dive into like very technical things here, that's kind of like the way we approach it, right? And there is like multiple names for this, like you can hear like maybe outbox, something like that, which essentially is exactly like this. It's just like slightly different, like replayable, if you will, right, way to track things. But long story short, we just decouple our database from the external services, and that's pretty much it. Which then also something that a lot of systems just omit and don't do for some reason, introduces a bunch of other problems, right? Because now we have, obviously, the system is not, it's not a single system anymore, so you need to account for like multiple things that can happen. And in this case, again, I hope you can read it, and I think you should be able to read it. So in this example, like obviously, first we get like our inline flow, which is what we just saw on the previous slide. Then you obviously want to have like a webhook, because there is no guarantee that your inline flow has ever gonna even like reach the point where you finalizing the order, right? And then on top of that, like you obviously want to have like a reconciliation job that you're going to run on a daily basis, because like again, webhooks, they also going to be lost, and it's going to happen for sure. Which all, by the end of the day, like all of them, right, they are pointing to the same thing, and they are relying on the same logic, which again, we need to make sure that we make this this core actually, this core logic part reliable by, again, properly applying logs. Now, again, this is not like a database talk, so we are not going to dive into like very technical details, but just like, I mean, when it comes to the databases specifically, just be very careful in how you log things in the database, because select some, I mean, like there is like a lot of things that are going under the hood, so just log them one by one in proper order and not try to do something like select multiple records for update. It may not work as the way you think it will. All right, and now that we are approaching essentially the other few interesting things that also sometimes are not even considered in a lot of applications. Now, there is, like, we just saw like very straightforward, right, like essentially race condition thing that can be solved just by applying logs, but not everything can be solved with logs. And one of the examples that you can see here is, well, like inconsistent dashboards, which also happens like almost everywhere. Essentially, what that means is like, it may as well just be a large report. So what that means is, imagine you generate something and you make a number of SQL queries to the database to get certain results. And obviously, like things can change in between these certain SQL queries. So you, like in system that is changing as you go, like you quite often gonna end up with something like this, where like your total number, for example, just does not match the numbers that it consists of, like essentially the number that, again, like how do we fix it? It depends. Like one of the ways we can fix it is by using proper transaction database isolation level. It does solve some problems, just be aware and know that that can be the problem. So next. And I wish I saw what was that. Okay, yeah, next. Sorry, it's just like super small on the screen, barely able to see it. Okay, then just like a few more things on top of that, that obviously, like concurrency does not apply just to your databases. And race conditions, they also happen not just with the databases, but also with the processes that just happen in your system, right? That and one of the examples that I just made up on the fly, but there probably are better examples. So you could have like some background job or like service that runs something on like like once a day or whatever, right? And just also be mindful about like what happens if it runs multiple times. What if you somehow spawned like multiple instances, which actually can happen with like Sidekick, right? That guarantees, I believe, at least like in the free version, like at least one delivery, right? So you might as well just like spawn now again, like if you just kill something and it just respawned. So long story short, just build the system with that in mind, and you can, there's a number of services that you can, a number of approaches that you can take to avoid a lot of these issues. Like this is not like very self-explanatory, but essentially with advisory lock just relies on Postgres advisory lock, and there is a number of other things you can use, like you can use Redis lock, you can use even like shared mutexes as long as you run only one instance of your application. So, which will probably never gonna happen, but still. Yeah, I mean, the problem is still the same, right? Like it's just the difference, like what are you gonna use as the locking point? Well, and I mean, honestly, that's pretty much it. I guess just what I wanted to end it with is, let's just be more mindful in general, I guess, when we build systems and think about how they work under the hood and take into account like multiple things, like how your system behaves from the coding standpoint, right? Like what are the different entry points you have to the same path in your application, how your database behaves with all this, what are like, when do you need like when do you actually want your data to be like, when can you afford your data to be stale or incorrect, which is also like a case, right, sometimes, and when you really want it to be up to date and guarantee the correctness. And how do we do it? Well, we do it by properly designing the applications. We do it by not essentially having the app making 15 queries to the database from 15 different places and no one even understands where they're coming from, right? We have like some meaningful business operations that know what they're going to be dealing with, and they're going to be locking things properly upfront and in order that you want and the order that you know, right, etc. And yeah, I guess that's pretty much it. In case anyone has, yeah, go ahead.
Do you have opinions on using like a Postgres lock versus a Redis lock or the different types of distributed blocks?
Like, I mean, I honestly, like personally, I have experience with using, for example, Postgres, right? Like advisory locks in Postgres. And also I like have some experience with like Redis lock. I can't tell you necessarily like what's better because I don't think like there is a huge difference, honestly. Maybe there is, and I would love to hear. But the point here, I think, is not like what exactly you are using, right? But the fact that you have something at least in place, right? Might as well just use a file if you have like a single threaded server. So, but I mean, I would love to hear if there is like strict reason as to why you would avoid, for example, Postgres advisory locks in favor of like Redis. Yep. All right. Thanks.